Um, Good day, everyone. So today we're going to discuss about the orthographic drawing. So on our previous lessons, we discussed about basic presentations on how can we present a different objects in technical drawing. So most of the drawings presented on that on our previous topic is more on a one-dimensional presentation of object, but on orthographic drawing we can present our objects more pleasing to our eyes. It's and also it is easier to understand uh, the different view of the object. All right, in this presentation we will try to develop skills on how can we read and interpret a particular drawings using the orthographic view. Now, the orthographic word is derived from the two words, uh, two Greek words, orthos and graphos. So, orthos means to write, and then graphos means to draw. So, meaning we're going to present our drawing by writing all the dimensions and information of the object, and also, obviously, we can draw the object on a different views on the orthographic method, right? Now, in typical object, there are 6 views. So, what are those 6 views on an object? So, number 1, we have the top view. Number 2, we have the front view. Number 3, we have the right side view, left side view, back view, and then the bottom view. So those 6 are the basic views that can be seen in a particular object. So meaning, in this case, we're not seeing an object in one dimension, but more on a different dimension. All right. But since we are on the orthographic topic or orthographic drawing, there are only 3 principal views in the orthographic drawing. So number 1, we have the top view. Number 2, we have the front view, and then number 3, we have the right side view. So nakikita natin on the left side of your screen, meron diyang isang presentation of the isometric drawing. So analyzing this isometric drawing, there are 3 possible views in this drawing. So we have so we have the top, then we have the front, and also we have the right side view. All right. Now, so in this example, we can see there are 3 planes of projection in this object. So in this object is a cube. All right. So as we can see, we can view the object on the top view, and also we can view the object on the front view, and also we can view the object on the right side view. So technically, we have here the 3 dimension of the object. Alright, so we have the next object. So again, we are seeing the 3 planes of projection in this particular isometric drawing. So in the middle of the presentation on the slide, we can see the isometric drawing of the object. And then also, viewing the top view, we can see this is the object for the this is the view for the top view object, and then this one is the right side view of the object, right? And then next one is the front view of the object. Now, if we are on the front view of the object, so this will be the POP of the object. So POP means the point of the projection. So this is the actual view that we can see on the front view of the object. All right. If we're going to change our point of view or point of perspective on the top view, seeing the object on the top view, we can project this is the This is the projection on the top view object. Now again, changing the POP or the point of projection, we can see the right side view of the object projecting this side. So this will be the output for the right side view of the object, right? Then next one. So we have here the third example. So we have the three planes of projection. So in the middle of the slide, this will be the isometric drawing. So this one is the isometric drawing, and then this will be the front view, and then this one is the right side view, and then this one is the top view of the object, right? So again, by simply changing the POP of the object, we can see the different side or different view of the object, right? So depending again on the POP of the object. So let's watch here a simple presentation on how can we project, or how can we draw a different projection using the orthographic projection. So again, there are three possible projection or three possible view on the orthographic projection. Again, number one, we have here the the front view, then we have the top view, and then we have the right side view. Now let's watch this video.
In this exercise, we're going to create an orthographic projection of the object shown. The first step in creating an orthographic projection is to choose your front view. Then all of your views are based off of that. The way this part is oriented, you would be tempted to call this your front view, because that's what looks like the front view. Now in this case, it's a little more complex because the front view is really the view that shows the most about the object. But if you look in this direction, really all you see is a rectangle. So in reality, we should either choose this side or this to be our front view. However, we're just learning how to do orthographic projections, and to choose either one of these views would be a little confusing. So I'm going to stick with the front view that's sort of shown in the figure. But just keep in mind, this is not really the best front view. Alright, so if this is our front view, then this is our right side view, and this is our top view. Alright, now to get a better handle on visualization, what I like to do is shade in all the surfaces that you're going to see when you're constructing a particular view. So if we're doing the front view and we're looking this way, we would see this surface, that surface, and that surface. So let's go ahead and draw that. So when we draw it, we're going to see these shapes, right? So that's what we should see in the front view. Now we don't have any dimensions. That's fine. We'll just kind of guess at the distances. Alright, you can see that we have this rectangle here on the top, this here on the bottom, but we need to indicate where that surface starts to bend. Alright, so that's our front view. So you can see why this is not a terribly good front view, because it really doesn't show a lot about the object. Alright, next we'll create the top view, and the top view is vertically aligned with the front view. So I'm going to draw projectors up from every corner and edge of the front view. And if we're doing the top view, we're going to be viewing down this way. We'll see this surface here and this surface here. So the top view will have these shapes. Alright, so I'm going to fill in this rectangle here first. And then we have this shape. So we know by the projector this is where it starts to angle back. And there we go. So that's the top view. The right side view is going to be horizontally aligned with the front view. And then we're going to create a 45-degree angle projector and project over and down from the top view. And this gives us a nice little area where our right side view is going to go. So if we shade in our surfaces, we're going to be viewing this way. We're going to see that shape, and we're also going to see some of the angled surface. Alright, so let's draw this shape in first. And the projectors will guide you. And then the angled surface. Alright, so that's our right side view. The last thing we need to do is to erase our projectors, or if you're in a CAD program, just turn that layer off so that we don't get confused with what our visible lines are and what our projectors are. And my suggestion is when you're sketching these orthographic projections, if you're just beginning, definitely use a pencil because you're going to be erasing a lot.
Okay, so as we seen on the video, we already know how can we project a different projection on the orthographic view. So one thing is sure is that number one is you have to identify where is your POP or point of projection in the particular object. So you have to find the point, the front view of the object, and the rest you can find the right side view or the side view, and also you can find the top view of the object. Now, in a technical drawing or engineering drawing, there are different types of line that can be used in order to present our views or our object. So number one is the letter A is the continuous stick line. So letter A is can be used to draw or to display the outline edges of the object or the main drawing. So most of the time we can use the HB type of pencil. Letter B is the continuous thin line. We can use this line to present a dimension, extension, projection, leader line, and so on. So we can use the 2H pencil with regards to writing or drawing a thin line, continuous thin line in our object. Then we have here letter C, continuous thin freehand line. So we can use this to show short break or irregular boundaries of the object. And then letter D, we have the continuous thin zigzag line. We can use this to show long break on the object. Letter E, we have the dash line. This line is used to show the hidden edges of the main object. And then we have the last three. We have letter F. We have the dash thin lines with dots. We can use this line to present a center line or center line for circles and arcs. Letter G, we have the chain thin with thick ends. So we can use this line to present the location of the cutting plane. Then we have letter H, the last one. We have the long thin dash and double short dash line. We can use this in presenting a front of cutting planes or outside of the adjacent parts of the particular object. So those are the basic example of the lines. Now let's watch this short video showing how can we use the different types of lines in technical drawing.
Welcome to Guide. Today we are going to learn about the types of lines used in engineering drawing. Thick continuous line. This line is used to represent 1. Outlines, 2. Visible edges, 3. Surface boundaries of objects, 4. Margin lines. Hidden line is indicated by thin short distances in between. Hidden line is used to show existence of a hidden edge. Center line. Center line is indicated by thin short distances in between. Cutting plane line. This is thick broken line that is terminated with 90-degree arrowheads. The arrowheads indicate the direction of cutting plane. Dimension line. It is a thin continuous line used to indicate dimensions of an object. Hatching line. It is a thin continuous line, used in different patterns representing the types of hatch. You can hatch an enclosed area or hatch within a specified boundary using hatch. Leader line. Leader line indicates details of the feature with a local note. Long break line. It is represented by a thin continuous zigzag line. For more updates, subscribe and click on the bell icon.
Alright, so those are the examples of the lines that can be used to present our our object in technical drawing. Now let's watch again the another example for the types of lines.
In my last video, I showed you 4 basic types of lines used in technical drawings: object lines, hidden lines, center lines, and construction lines. In this video, I'll show you a few more types of lines that you should know about to create professional quality technical drawings. Sometimes it's useful to break away part of an object so we can see what's underneath. When we do this, we need to indicate which part of the material has been cut using section lines. Section lines are bold, parallel lines that are drawn at an angle on the surface that's been cut to reveal the inside of the part. These lines should appear only on the cut surface and should not be drawn parallel or perpendicular to any of the object lines that make up the edges of the surface. There are 2 ways to create a section view, and they both use their own new types of lines. The easiest way is to create a short break. In this technique, a jagged line shows where the surface of the object has been torn away to reveal the details underneath. This short break line shows us where the section area begins, and the section lines indicate the material that has been torn by the short break. The other way to create a section view is to slice through the object in one view and to show the cutaway section in a second view. To do this, we need a cutting plane line to show where the part has been sliced to make the section view. A cutting plane line is the boldest line on the page and uses a double dash pattern. On the end of the cutting plane line are arrows that show the reader what direction the section view will be looking towards, and usually a pair of letters that correspond to the section view in case there are more than one cutting plane line and section view on the drawing. In this case, we will see the entire part in the section view with the front material removed as shown by the cutting plane line. The entire cut surface is indicated by section lines. If the part being drawn is very long and has no special details along its length that need to be shown, the drafter might shorten the object to fit onto the drawing page using a long break line. This line is used to cut out a section of the part where the cross-sectional details are the same, and the length of the part would make it too long to fit on the page. Both ends and any important details can still be dimensioned, and the reader knows that the missing portion is the same as the parts that are shown. When it's time to dimension the drawing, there are a few new types of lines that we need to know about. Normal linear dimensions use straight lines with dark arrowheads called dimension lines. These lines typically point outward from the dimension, toward the extension lines. Extension lines are used to extend the edge of the object that needs dimensioning so that the dimension line can reference it without touching the object. Extension lines should be separated from the object lines by a small space, and the ends of the arrowheads on the dimension lines should just touch the extension lines they refer to. If multiple dimensions refer to the same edge of the object, then both dimension lines will refer to the same extension line. Both dimension lines and extension lines should be a little lighter than the object lines and should be drawn using a straight edge. There are lots more guidelines needed to fully dimension a drawing view, and for that, check out my video, Dimensioning Basics. Some types of dimensions don't use regular dimension and extension lines. You might see whole notes or radii dimensioned using a leader line. Leader lines are similar to dimension lines, but they extend from the dimension all the way to the object edge that they refer to. The arrowhead touches the line exactly and points in the direction of the hole or arc center. Try to avoid drawing leader lines vertically, horizontally, or passing through a corner of the drawing view. Occasionally, different types of lines will overlap on a drawing view. When this happens, one of the lines takes precedence or comes to the front of the view, and the other line falls behind and may not be seen. For example, if an object line falls in the same location as a hidden line or a center line, the object line takes precedence, and the other line is not seen. Hidden lines will take precedence over center lines if the two should overlap, and cutting plane lines would take precedence over all other types of lines.
Okay, so those are, again, the other examples of the types of lines that can be used on the technical drawing. Right? Now next. So before we proceed on the exercises, again, in this slide, we presented about the orthographic projection or orthographic drawing. Again, there are three possible, or based on the principles of the orthographic drawing, there are three possible view. So we have here the top, we have the front, and then we have the right side view. And then also the slide presented the different types of lines that can be used to present our particular object. So on the first exercise, let's see what's on the exercise. So we have here an example of isometric drawing. So we have here the three types, or we have the three views of the isometric drawing. So we have the top view, then we have the front view, then we have the right side view of the object. So all we need to do is to find the matching number on the isometric drawing of the object. So we have here the table, right? So So if we're going to find the matching face or the surface on the isometric drawing, so let's say we have to find letter A on the isometric drawing, or I mean on the orthographic drawing. We can find this A, or the matching surface of A is number 3, right? And then we have the surface B, so the matching surface B on the orthographic drawing is on the side view of the object. So this is the number 6. This is the matching surface B. So number 6. If we're going to find the matching surface C on the isometric drawing, we can find this object on the front view of the orthographic drawing, which is the number 4, right? And then if we're going to find letter D on the surface of the isometric drawing, we can find this on the right side view of the object. So this is the matching surface on the isometric drawing. So this will be the matching side of letter D. Then how about letter E? So letter E of the isometric drawing can be found on the top view of the object on this surface number 1 on the orthographic drawing, right? How about F? So F is can be found on the side view of the object number 5 on the orthographic drawing on the right side view. And then the last one is letter G. Letter G can be found on the top view of the object, particularly on the surface number 2 on the top view of the object. Alright, then next, so we have here 2 examples of the isometric drawing. So this one, and then we have here the second object, right? So notice the arrow. So the arrow here signifies this is the front view of the object. All right, so all we have to do is place the letter or transfer the letters from the isometric drawing to the surfaces of the orthographic drawing. So in this video, we're going to answer the first object only. So this isometric drawing only. So this will be our front view, this will be our top view, and this will be our right side view. Alright, so the F here, we can put letter F in this surface of the front view object, and then this will be letter E of the surface. And then if we're going to proceed on the top view of the object, this one should be letter D, and then this one should be letter B, and then the last part or the last surface is letter C. So this will be letter C. And this one, the last side, we have here the right side view of the object. We can only see 2 possible side or surface in this plane. So this one will be the surface for A, and then this one, the upper one, the upper surface should be the surface for letter B. Alright, so those are the topics that can be discussed or can be presented on our topic for the orthographic view. Right, so again, the orthographic view, based on the principle, we have only 3 possible views. So we have the front view, we have the top view, and then we have the right side view of the object. And then we can use different lines we can use different line to present our object. So mostly our lines are the object line, and then we have the dimension line, Then we have uh, the hidden lines. So those are the basic topic or the basic line that can be used on the technical drawing. So again, thank you, and then please watch the next video for the next topic, probably next week. So again, thank you so much.